All right, looks like we're off. Hi, everyone. My name is Kristen Torrance. I'm a learning experience designer at an XR platform company called Tailspin, where I design immersive learning solutions. And we'll be talking about using learning analytics to measure competencies in educational games. So before working at Tailspin, I worked for a K-12 edtech company where I helped design educational games for elementary and middle school students. And while I was doing that work, I was researching game-based assessment methods, and I discovered this framework that I am excited to present to you today. And since then, I've applied this approach toward assessing learning in virtual reality. So let's see how we can use xAPI to facilitate learning analytics, measuring competencies in educational games. So first, we will cover the measurement methodology and that this entire assessment framework is based on. And then we'll discuss some game-based use cases that implement this framework and sort of get an inside view on the xAPI behind that. And then we'll end on really how you can use this framework to design your own game-based assessments. So this measurement methodology is based on the evidence-centered design for assessment framework, which is a systematic method of designing assessments focused on evidence of competencies that are the basis of constructing learning activities, and here it's applied to gameplay and game-based learning. And so what evidence-centered design is a conceptual framework that supports the design of valid assessments. So it allows designers to align claims that they want to make about learners to things that learners actually do within the context of the game. And it's really centered around collecting empirical data from the learner. So by approaching game design with the end goal of assessment in mind, then we're able to intentionally design game activities aligned with target competencies. And learners interact with the game activities that we then develop and create, and those actions, they act on the environment, they make decisions. So those actions then produce evidence that we can use to infer learner proficiency. So in other words, evidence-centered design allows us to make evidence-based claims about learners. So by knowing what we want to measure, we can design activities that solicit learners' execution of these competencies. Then we can evaluate their performance and use their proficiency with the task to make inferences about their competency levels using statistical modeling. So you may ask why we may even need this sort of framework. And the short answer is flow. So if you can, maybe add some reactions if you've ever heard of flow. Looks like there's a couple. Yeah, so for those of you who may be unfamiliar with flow, it's basically a state in which that you're completely absorbed in this activity. It's sort of this optimal experience where really all else is ignored. And it's achieved when you strike this sweet balance between challenge level and skill level. And as learning designers, getting learners to reach a flow state as they're learning is like the holy grail of learning experiences. So if you can imagine, once we get a learner there to that flow state, really the last thing we want to do is pull them out of that state, and especially doing so for assessment. So thankfully, there's been a lot of research done in the video game industry on game-based assessment. And this is where the concept of stealth assessment comes in. And we'll talk about that a little more. But the key thing about the stealth assessment framework is that it's based on what is the evidence-centered design framework. And it allows you to assess learning without disrupting flow. So evidence-centered design does this through the interaction of three primary models: the competency model, the evidence model, and the task model. And so if you go from left to right, so from the competency model to the task model, it's a design framework for how to design gameplay experiences that are intentional and focused and collect evidence of the competencies that we want to measure. So in identifying what we want to measure, how we're going to measure it, and then where we get the data. But if you move from right to left, so from the task model to the competency model, then it's a method of measuring competencies based on evidence collected using predictive modeling. So given the data that's collected in the task model or the game, what does this evidence say about learners' performance? And how does knowing this shape our inferences about learners' competency levels and what they can do? So the competency model, to kind of zoom in here on a little bit more, it specifies the competencies to be measured by the game assessment. So this model, as you can see here, it operationalizes a larger abstract competency construct into these observable indicators that are visible in the game environment that we can then build triggers for and send to the back end. And the evidence model, so this specifies what observations would provide the best evidence of the competencies in our competency model. And this includes two submodels, which we call the evidence rules, which is really the assignment of scores to observable behaviors, observable indicators in the game space, and rating them on different rubrics, and then assessing what that level of competency is at that level. And then it's also comprised of the statistical model, which is really the probabilistic relationships between the behavior we can observe, so the evidence collected in the game, and the competency facets that it's related to. And we'll show a little bit more how this works in the use cases. And then finally, the task model. This specifies the types of game-based tasks and features that should be designed and developed that work to solicit this evidence of target competencies from the learners in the game. This is the really exciting part, right? It's what we designed to put in front of the learners. So again, these models flow into one another, and you can think about them in terms of the flow of learner activity, but also the flow of learner data. So what's interesting about that evidence-centered design framework is that you can actually just stop there, right? And have a very sound, valid measurement model for assessing players' competency. But with what we call stealth assessment, it takes it one step further. So stealth assessment was pioneered by a researcher out of Florida State University named Dr. Valerie Shute, and she has recently retired. But it is based on the evidence-centered design framework. And what it does is it circles back that information of learner competency to influence the level and progression that the player experiences in the game, to then present new tasks that the learner must then play and then are further evaluated. So it is this continuous cycle. And she named it stealth assessment because the assessment is woven into really the fabric of the game. So learners are being assessed without them actually knowing it. And we'll go a little bit more into that in the next use case. Let's see. So yeah, evidence-centered design and stealth assessment. So here is an example. And I know you can't hear this, but that's okay. So we are going to start with talking about educational games first, then we'll move into entertainment use cases. So in this game, it's a physics game called Newton's Playground. And in this game, players draw shapes that then influence the trajectory of the ball in an effort to get to the red balloon. And this here's a competency model of the Newton's Playground game. And this shows how competency models can be combined to represent even larger learning experience models, such as success in a physics game. And so you can see here, success in this game is broken down into 3 different competencies, each with their own competency model. So creativity, conscientiousness, and qualitative physics. And then these yellow boxes here indicate the actions or the behaviors that are observable by the game system that then feed into the competency model. So let's take a deeper look. This is a competency model for creativity. And you'll see that sometimes facets will have multiple observable indicators in the game, such as fluency and flexibility. Or sometimes they may only have one, such as problem solving in this example. And you may notice something really interesting about this competency model is that not every facet has an observable indicator. So you can see here that every construct in cognitive skills has an observable indicator associated with it, but this entire disposition facet here at the bottom cannot be observed through players' actions in the game. Do we think that this is a problem? So we can only collect evidence for cognitive skills. Is this an issue for us? So if we take a moment, click a reaction button if you think that this is a limitation of the model. Okay, we got a couple more coming in. Click the reaction button if you think dispositions are just a construct that we'll need to measure outside of the system. Oh, apologies. All right. Well, thanks for responding, and sorry about that hide button. Hope that you can now access it. Well, that was actually a trick question because it's actually neither of those. So we are, in a sense, able to infer dispositions using cognitive skill observable indicators. And really, that's the beauty of these competency models representing probabilistic relationships, is that the inferences can really move both ways. So the inputs in the form of empirical evidence comes from the observable indicators, these here in the yellow, and those enable us to infer the level of proficiency, flexibility, originality, and thus predict cognitive skills and predict level of creativity. And because these are all connected, knowing the probability that cognitive skills is at a certain level, we can then infer the probability of dispositions and its subconstructs to be at a certain level too, using Bayes' theorem, which is calculating the value of disposition given what we know to be true about the probability of cognitive skills. And, of course, the more and more data that the system collects through learner interactions within the game, the more robust these predictions become because there's more data to support and base these inferences on. Here's another example of a competency model for conscientiousness, and you can see here a similar relationship with carefulness. And a third competency model for that third competency within the physics game, which is Newton's 3 laws. And we will see here in this next slide, really this is remember, a probabilistic model. And for Newton's 3 laws, this is the probability distribution of each of the variables. So these are prior probabilities of the statistical model, which represent the likelihood of the competency levels. So for instance, the probability that someone will be competent in Newton's 3 laws is about equal for high, medium, and low. And so given these statistical probabilities, how does this all sort of work with the evidence model? Well, posterior probabilities, this refers to the resulting probability once evidence is entered into the model. So it's really the revised or updated probabilities of these events occurring after taking into consideration new information. And the new information comes in the form of gameplay. And this is, updated again using Bayes' theorem, which in statistical terms is the probability of event A occurring given that event B has occurred. And then each of these competency facets at the lowest level, you can see here, down here, those are associated with these observable indicators that you can see in the game. So when the game system analyzes the log data, the performance of those evidence indicators then gets inputted into the model to predict the higher order competencies. These are the sorts of the game's tasks that were assigned to the player that enable the system to gather evidence, really with the common premise being around getting the ball to the balloon. So rolling it up a hill, maybe catapulting it to the balloon, and so on and so forth. So again, Newton's playground employed this stealth assessment cycle, right? So first, the game activities were presented to the players in the form of the designed task model. As a result of that gameplay, the system extracts the observable indicators from the log data, and then as part of the evidence identification step. And number 3, those indicators are then evaluated as part of the evidence rules, and then these outcomes are fed into the competency model. And then based on the predicted competency levels, the game selects the next activity to present to the learner, and then the cycle restarts. So let's look at sort of the mechanism behind that. So here's an overview of how data really flows from the front end client server to the back end scoring server. And Newton's Playground was built in Unity, so that's how the presentation process occurs. And Unity logs events in JSON, and they can be extracted using xAPI and stored in a learning record store. For this particular game, they used Learning Locker. And then these events were sent to the backend database, and they used MongoDB. So you can see how there were 2 different servers, right? There's the client server and the scoring server. So in the scoring server, was the evidence identification step, the evidence accumulation step, and activity selection. And so evidence identification, what happens here is that it fetches all of the events from Learning Locker and since the last timestamp since it last fetched. And it recodes these xAPI events into what are simpler proc4 message events. And then it updates the timestamp to the last timestamp in the message set. It filters out all of these unused events, and then it loads events into the process queue. And to kind of touch on that, Newton's Playground used proc4 messages, which is essentially sort of the simplified version of xAPI statements. And it's really just to lighten the load and only pass through the necessary information that the game client needs to then inform gameplay. So when a player first logs into the game, the competency model gets copied and to make sort of this player-specific competency model. And when this evidence identification proc4 messages are stored in the scoring server, the evidence accumulation occurs. And what happens is that it finds that player-specific competency model, and it instantiates the observed variables and then propagates evidence into the model, which then records the updated competency model probabilities. For activity selection in Newton's Playground, the game levels, really sort of the way they were organized is that they were split into topics associated with skill variables in the competency model, and those topics were sequenced from high, medium, and low within the topic. And the way that selection logic occurred was, or the way it works rather, was that if the probability of competency was above a certain threshold, then players can graduate to a next topic. If the probability was below a graduation threshold, then they would give either the low, medium, or high difficulty test, depending on the skill variable score. And it would sort of work like that. So if they were out of tasks for the group, then they'd give a task from other groups. If they run out of levels on a topic, they'd move on to the next one. If the player graduates from all topics within the game, then the game is over. So that's really sort of how the logic behind activity selection worked. So again, sort of the simplified version of the stealth assessment cycle. The gameplay occurs, that is stored and analyzed. The system then has a better idea of the learner's competency levels and can adjust to provide the right level of game activities. All right, so on to our next use case. Please add a little reaction if you have ever played Plants vs. Zombies 2. Cool. Oh, looks like a lot of people. That's great. So for those of you who have not played in this game, you have a army of plants that you strategize so that your plant army defends you against these really funny zombies. And really the challenge here comes from determining which plants to use and where to place them in order to defeat all of the zombies. Researchers then use this game to measure problem-solving skills in a modified version of Plants vs. Zombies 2. So if you can take a look here on the right side of this image, you can see that some of these zombies are frozen. One of the plants in the game is called iceberg lettuce, which lets you use, it lets you freeze an incoming zombie attack temporarily to delay the zombies. And players use this iceberg lettuce when players use it, and where they place it is an observable action in the game. And it's something that can be seen and measured and stored and extracted as an event in xAPI. So this is the competency model for problem solving in Plants vs. Zombies 2. And they came up with 4 main facets, which include analyze givens and constraints, planning a solution pathway, using tools effectively and efficiently, and monitoring and evaluating progress. And these 4 facets have been further operationalized into these observable behaviors we can witness in the game. And you can see here that the use of iceberg lettuce is an observable indicator of the using tools efficiently and effectively facet. So this table illustrates sort of the specifications for how the system detects when an indicator is triggered and how it is sent to the back end. I will spare you the details, but if you are collaborating with game developers, creating this sort of documentation is really helpful in being able to track what you want to track, or at least the events in Unity. So here is a Bayesian model for the prior probabilities for that problem-solving skills competency model. So starting from the top, the likelihood of someone having a high, medium, or low problem-solving skill is about equal for all. And that same general trend occurs at the second tier as well, with a little higher probability in the middle. And the probability distributions in the third tier are a little bit skewed. So it's a little bit more likely someone will demonstrate a very good or good tool use from the indicators versus okay or poor. So these are before any evidence is entered into the system. Now here's a model of the posterior probabilities. And so this is the resulting probability once the game has collected evidence. So data is then entered into the Bayes nets. You can see here that poor use of iceberg lettuce, which was indicator 37 here in the gray, that is actual accumulated evidence from the game. And so we have witnessed a player's poor use of iceberg lettuce. And from that, we have been able to update the Bayesian statistical model to get a better idea of learners' competency. So we can really take a look here how much the probabilities have changed from prior to posterior. And it is pretty drastic. So before, the likelihood was about equal for all levels, for problem-solving skills, and even for tool use. But with knowing this new information, which is, again, observed demonstration of poor iceberg lettuce use, we can now infer that it's likely the learner has a low tool use skill, as well as a low to medium, actually, level of problem-solving skills overall. And you'll notice that the evidence didn't just affect the probabilities linearly. It also affected the other probabilities to those connected to in the entire competency model, even the ones, even other indicators. So you can see the neighboring probabilities have also changed. And again, it is a part of that self-assessment cycle. So the gameplay, storing log data, analyzing that log data, updating the competency models, and using that to inform what learning activities are then presented into the game. And the types of tasks that were assigned to players that enable really the game system to collect this type of evidence were sort of these examples. So survive and protect the endangered plants, or defeat 8 zombies in 10 seconds, or survive a zombie attack with the given plants. So this is Elder Scrolls Oblivion, and let me know by reacting in Aramie if you've ever seen or heard or played this game. A couple. Great. So Elder Scrolls is it's an open world action role-playing game, and it's from about 2006. And here is an overview of what the evidence-centered design model looks like for a small snippet of Oblivion. And you can see here how the models flow into one into the next. So efficiency and novelty are really the most observable competency facets in the competency model. So that is where what the evidence that we're collecting will inform those competencies. So in the evidence model, you can see the statistical probabilities that connects the facets to the task. And again, the task model is really about the context in which the game's evidence like indicators of competency are being collected. So the quests or the missions that the learner, the player goes through and completes that we then use as evidence of these competencies. So here's a full competency model for success in Oblivion, and it's divided into two first-tier facets, which are cognitive and non-cognitive skills, both of which can be operationalized further into second-tier facets. And then you can see creative problem solving is a predictor of both cognitive and non-cognitive skills that are being assessed in the game. And it has its own competency tree, just like the others. And creativity you can see here, is also operationalized further, and so is problem solving, but creativity connects to both efficiency and novelty. Here's an example of the Bayesian network of the prior probabilities for the creative problem solving competency model. You can see the likelihood here of someone having a low versus high creative problem solving is about 50-50. And the remaining variables have a somewhat similar likelihood. And then here are two examples of evidence being entered into this system. So the one on the left is when learner demonstrates a low efficiency skill and a high novelty skill. And with this new evidence, the model now predicts that it's likely the player has a low level of problem solving skill and a high level of creativity skill. And then overall, the likelihood of them having a low creative problem solving skill is 60% versus high is 40%. In the second example, on the right-hand side, the evidence observed was high efficiency and high novelty. So you can, obviously that leads to a predicted high efficiency, high novelty, predicted high problem solving and high creativity, which predicts high creative problem solving. And these are really the types of actions within Elder Scrolls Oblivion that the game system tracks and triggers. So swim across a river filled with dangerous fish, levitate over the river, find a bridge over the river, dig a tunnel under the river. So those are just sort of the game activities presented to learners that that the system uses to gather evidence of competencies. World of Goo is another puzzle game. And in this game, you can really sort of drag and drop these living, squirming, talking globs of goo to build these structures and bridges and all sorts of things. Also sort of a physics game. But the competency model for World of Goo, this is a competency model specifically for one of the levels called Fisty's Bog. And in this level, players need to use different types of goo to cross through an area with spikes on the floor and the ceiling. And this level deals with finding equilibrium between two opposing forces, which are gravity and buoyancy. And it consists of three primary facets. So problem solving, causal reasoning, and static equilibrium. And you can see that those competency facets are further operationalized into third and fourth tiers, the fourth being the most observable and what we can see and track in the game. Another example of what this Bayesian model looks like, this probability model, and an example of how, when evidence is entered into the system, how it affects the probabilities of players' competency in each of these sub-competency facets. And some of the tasks that were presented to players in Fisty's Bog were identifying use of balloons, avoid upper spikes, avoid bottom spikes, modifying your hypothesis to solve problems in subsequent gameplay. So these are just sort of the indicators that the game and the logs are looking for to inform our competencies. And again, this was utilized the self-assessment cycle. So let's get to the really exciting part, which is how you can employ evidence-centered design into your game-based assessments. And this also doesn't just apply to game-based assessments. In our practice, we apply it to designing virtual reality training. You can use it to design e-learning. Funny story, fun fact rather, evidence-centered design was first conceptualized in adaptive testing. So it really came from this rigorous, assessment, measurement methodology model. It was invented by the creators of the GRE, Education Testing Service. So it is highly applicable to really all learning and all learning solutions, I'd say. So developing a competency model. So this model really asks, what are we measuring and what do we want to claim about a learner? So self-assessment and evidence-centered design is a measurement-first, competency-first perspective. So it asks you to define the knowledge, skills, and abilities inherent in your learning objectives. And once this is defined, you can create a competency model by unpacking or further operationalizing competencies from the unobservable to the observable, ending with the behaviors and actions that can be observed within the game. You can see here on the very left-hand side of the diagram, you begin with a competency, and as you unpack it, you move more to the right. The competency facets become increasingly observable, ending with the indicators on the very right-hand side. And these, not just games, it could be, these are what's observable in any of your learning solutions, whether that be e-learning, whether that be immersive learning, or game-based learning. You can also, during this stage of developing a competency model, you can collaborate with subject matter experts to really help you define these learning objectives, defining these competencies, right? And unpacking what each of these competency models look like from the abstract to the more observable indicators. And they can help you model how these facets relate to one another. when you're developing an evidence model. The evidence model, again, is really the true bridge between the gameplay experience and the competency model. It's made up of two different models, the statistical model, which interacts with the competency model, and the evidence rules, which interacts with the task model. The statistical model, again, is a model of the probabilistic relationships between competency model variables and the observable variables. And the evidence rules is really how you create the creation of rubrics to measure the observable facets and then classifying their levels of performance. We often would collaborate with SMEs or data scientists to build out these statistical models of these probabilistic relationships using Bayes nets or item response theory. To get the data from your game system, you can write the xAPI statements yourself. If you don't know how to do that, or your game developers are really the only ones dealing with that, you can collaborate with your game developers and collaborate with them to build in these triggers that identify and evaluate evidence using the scoring and categorization levels that you define. And then finally, the task model. This is really about ideating the design of the learning experience, right? So how do we create opportunities for learners to demonstrate the competencies that we want to measure? The question we ask here is, how can we observe learners do this? So again, mapping back to the competency model and the evidence model, what does it look like in the gameplay to demonstrate the competency facets that you want to measure? Again, this is the really fun part. It's the design, because you can come up with a variety of really creative scenarios that can solicit this sort of skill demonstration. So I would recommend you trying it out. Even if you don't have access to game developers or data scientists, or really if you have no intention of building the models out in the game system, just applying evidence-centered design to your next ID project can really help bring focus into focus, really, what needs to be learned, how it can be evaluated. And it also provides a really great approach for a very focused and intentional learning experience design ideation session. I do have a recap slide, but I know we're running out of time, so I want to get to questions. So I'm happy to open up the floor.
Actually, go ahead and recap. It takes people a couple minutes to
Okay.
Make sure it's a good question and then type it out, fix their typos and stuff. So everybody,
Absolutely.
Go ahead, put your questions in the Q&A. I'll serve them up to you, Kristen, but if you want to do your quick recap, that would be awesome.
Absolutely. So just as a quick recap, evidence-centered design for assessment is a framework for embedding assessments into gameplay without disrupting flow. And it's both a diagnostic framework and a design framework. And again, this can be applied not only to game-based learning, but immersive learning or e-learning, even things like if you work on cognitive tutors or things like that, this sort of assessment is really useful. A competency model, this operationalizes unobservable competencies into observable indicators that we can see, and also maps their interrelationships. The evidence model takes in data from the task model and evaluates it using evidence rules. It's passed along to the statistical model and updates probabilities that predict competency level of learners. And then the task model, this really constructs the gameplay activity that learners participate in. And it tracks learners' actions and converts this data into a usable format to then feed into the evidence model. And close to my last slide, I have references. All of these are all of the studies. I think everything's linked. Yeah, everything here is linked. I've discussed pretty much all of these studies today, or in today's presentation. If you have any questions, please feel free to reach out, or if you need access to any of these any of these research studies, please do let me know. I do have them on file or know where to access them. And yeah, so thank you so much. And I hope I've made you as excited about evidence-centered design and self-assessment as I am.
Awesome. All right, we do have some questions.
Perfect. So do you have any templates or other resources that could help people apply this model in their instructional design? Let's see. I don't, off the bat, I don't have any templates. I do have a handout that I created for DevLearn that is, the handout is specific to designing for VR for immersive environments. However, it really could, as I mentioned before, could be applied to any learning solution. And it's sort of this, I wouldn't call it a step-by-step guide. It's basically the framework, but sort of talks a little bit more about how the framework is done and some examples as well.
Awesome. Awesome. So next question.
Okay.
There we go. We've got some good questions here.
Great. Oh, and just to touch back on that last question, Andrew, I think it's a really great idea to start making templates for it, because I think I would honestly find it very helpful. So something for me to work on, and then I'll get back to you. I'm struggling with a use case for this. Would it be used in recruiting, as in understanding people's strengths, or where? I can't see using the game for any kind of corporate training. Well, so you may not be using Elder Scrolls Oblivion for your corporate training and creative problem solving. However, just really the model itself, this evidence-centered design model, is really helpful in, we apply it in immersive learning. So, and scenario-based learning, really. So, in scenario-based learning, you're often presented with these decision points where which are often branching, right? And you can use these decision points as evidence of competencies. And so you can actually, through a branch narrative, track various decision points within a scenario-based learning conversation or, task. And depending on, what things you want to measure or what competencies that particular narrative flow is meant to assess, you can map that evidence, to the competencies in hopes to predict or the competency levels of your learners. So self-assessment specifically, and also evidence-centered design, it's kind of like an underlayer of the learning solutions that you'd want to create. I hope that answered your question. I know I went a little in circles.
Cool. Now I've got one last question for you.
Okay.
It looks like it's from me, but it's actually from Helen.
When you start a project of these models, which one do you share first with your subject matter experts / team members? Yeah, that's a great question. So competency model, I would say, is really the first thing. It really helps center around, what exactly you want to measure and what does that look like and what are all the different ways in which it may look like. So I like starting with the competency model. I kind of like going in that same flow. So competency, then evidence, then task. So starting with the competency model, once you can operationalize from something abstract such as creative problem solving, right? If you can deduce these identifiers of, this is exactly what it looks like to demonstrate creative problem solving. These behaviors are indicators of problem solving. Then you can think about, so if I were to observe that, how would I rate that? Is in high, medium, or low? What is that? What are the criterion for what qualifies as a high, indicator, a low, and a medium? And then based on all of those, come up with these activities, or I would call them activities. I don't want to say game activities, that you can present to learners that that will then solicit evidence of those competencies.
Awesome. Awesome. Okay. We are just about out of time, but I'm hoping this one might be fast. I realize this one is not fast. There's a lot of depth. And I know that Julian is the kind of person who needs a lot of depth. So this may be just a Kristen, meet Julian. Julian,
Okay.
meet Kristen. But if there is a fast answer, it's all yours.
There may not be a fast answer, but Julian, if you want to meet at a round table after this, I'm happy to meet you there.
Good call. Good call. Kristen, thank you so much for joining us today. You can go meet Julian at a discussion table. In the meantime, we'll have everybody chill for about 15 minutes. We'll come back and have a panel discussion and wrap this up. So thank you so much, Kristen.
Thank you very much.